Now we're going to look at factoring the form ax squared plus bx plus c. So what's different from this one and the previous one is that now in front of that first term, you have a coefficient that's something other than 1. So just like on the last one, we're going to do our little quick recall. If we would have had 2x minus 3 in parentheses times 3x minus 2 in parentheses being multiplied together, the 2x in the front parentheses times the 3x in the front parentheses would give me my 6x squared. That would just get copied down. The minus 3 in the back parentheses times the minus 2 in the back parentheses would give me my plus 6. That would just get copied down. The 2x in the front times the minus 2 in the back with the minus 3 in the front times the 3x in the back would give me a minus 4x and a minus 9x that would combine to get the minus 13x. So basically the way the problem is broken up for our multiplication ends up matching what we looked at before when I gave the example of x plus 2 times x minus 3 and how we got the x squared minus x squared minus x minus 6. The thing that's going to change is that now I have a number other than 1 that's being multiplied from the front piece. That means I have to pay more attention to how I'm setting up my parentheses when I go to figure out that factored form. What I already have written down are the steps that we had last time when we were factoring the form x squared plus bx plus c. I'm going to make 2 quick changes and you'll see how everything else remains the same. So the first change I'm going to make is to write an a in front of the x squared. The second change I'm going to make is in the purple color where I wrote trinomial of degree 2 with coefficient of x squared equal to 1, I'm going to change that to not equal to 1. And everything else stays the same. So what I was telling you before is going to remain the same. So I wrote it in that fashion so that it would. It's just that I have to be a little careful with my parentheses. So pause the video. Make certain you have that down. Alter the original note if you want to from the previous video. And then when you're done, unpause it and we'll get started. So my directions are still going to say to factor. So I have 3x squared plus 20x minus 63. I need to factor. I'm going to pay attention to the first parentheses. The front part of the parentheses where I'm going to need the factors of 3. And then I'm going to have the second part of the parentheses where I'm going to need the factors of 63. So factors of 3, that's just 1 and 3. Remember the x squared part isn't a big problem. I'm going to split the x's evenly. Half in the front, half in the back. So that's not a problem. 63, it has the factors of 1 and 63, 3 and 21. Now, here's a trick. See, once you know it's 3 and 21, if I can think of something that goes into 21, I can take and I can throw it over there with a 3. So 21 is 3 times 7, so I'm going to take the 3 from the 21 and multiply it by the 3 that I already had written up front, and I'm going to get a 9. So 9 times 7 is also 63. And so you can play around with the numbers to kind of figure out those factors if you're not too good with the factors. Now here's where things are going to change. I can no longer just go to that second factor, figure out my plus minus, and then use it to fill in the parentheses. Now I have a little more work to do. Okay. I'm still going to use the fact that in this third term it's a minus, so I'm going to have different signs. Which meant I would have been subtracting, or I will have to subtract. To figure out what I'm going to use. In the second term, it's a positive. The higher product is going to be a positive. So since I have more to figure out, I'm not going to just come on the side where I have my factors and do my subtraction to see which one's going to give me a positive 20. What I'm going to do is I'm going to set up my parentheses and I'm going to just keep testing things out until I get a match. So I'm going to put my factors of the 3 up front along with my x. So 1x means I'm just going to write an x. A 3x gets written up front. What I'm then going to do is I'm going to pick a factor to work with. I am just to show you how it works. I'm going to pick 1 in 63. I'm going to put the 1 up front, 63 in the back. And then I'm going to play around with that middle pieces, the O and the I from the FOIL. The 1 in the back of the front parentheses times the 3x in the front of the second parentheses would give me a 3x. The x in the front of the first one with the 63 in the back of the last one would give me a 63x. If I were to subtract 63 minus 3 is going to give me a 60. That is not what we want. That means that's not the answer. Okay. Doesn't matter how I put the signs in, it's not going to work. So the next thing I'm going to do is I'm going to leave the x in the front. I'm going to leave the 3x in the front. And I flip-flop the order. I put the 63 in the back, and in the back of the first one, and the 1 in the back of the second one. So notice I left the 2 fronts alone, and I just flip-flopped the other ones. Because it may not have worked in the order it was in, but it may work if I flip it. So I flip the order. Now I check those same 2 things again. 63 times 3 is that 189. And x times 1 is a 1x. If I subtract that, I'm going to get a 188. So now that you've checked this 1 in 63 both ways, you know it's no good. So that 1 in 63 is not going to work with that. The 1 times 63 is not going to work with the 1 times 3. And the reason why I said work with the 1 times 3 is because if this front one of 3 had some other factors, then I would have to try the 1 times the 1 in 63 with another set of factors from the 3. In the beginning, I knew I didn't want to try the 1 in 63 because that 63 is such a big number. And I knew that just manipulating the numbers that I was not going to be able to get some numbers to subtract to be able to get a 20. So I intentionally picked that set just so we can see how it works. So now let's try another set. Notice I copied down the x and the 3x for the 2 fronts, and now I have to figure out the back. So let's try 3 and 21. So I put down the 3, I put down the 21. 3 times 3x would give me a 9x. X times 21 would give me a 21x. If I subtract those, I'm not going to get my 20. So now I flip them. So I leave the fronts alone and I flip the backs. Now I check. And it's not going to work either. That 21 times 3, that's too big. So now I need to try the 9 and 7. I've been trying them in order that they're written on the paper. 1 times 63, then the 3 times 21, then the 9 times 7. You don't have to try them in order. So I keep my x up front, my 3x up front on the second parentheses. Now let's try, what do we have left? 9 times 7? So I put 9 in the back of the first one, 7 in the back of the second one. And now I check. 9 times 3 is a 27. X times 7 is 7. If I subtract those, I will get my 20x. Now I pay attention to my sign. And now I'm also going to write this in black because I'm going to use that for my answer. I need it to be a positive 20x. The way that I have it written, with the 27 being positive and the 7 being negative, gives me my positive. If it didn't, I just would reverse the signs. I would just make, like if I needed a negative 20x, then I would make that positive 27, I would make it a minus, and a 7x I'd make a plus. The higher product is 27x. It has the positive because that's the positive 20x that I needed. That's the part where I was talking about higher product. 27 is the higher product. So that one's getting the plus. So that plus sign in front of the 27 is going to carry right in front of the 9. The x times the 7 is where we got that minus x from. So that one's going to go in front of the other one. So our final answer will look like this. X plus 9 in parentheses times 3x minus 7 in parentheses. Again, do your check to make certain that your answer is correct. Let's do another one, and I'm not going to torture you through as many trials. So I've written down the problem, 12x squared plus 17x plus 5. I've written down the factors of 12, 1 and 12, 2 and 6, 3 and 4, and the factors of 5, 1 and 5. Now I have to go and set up my parentheses and play around. So now you have to decide which set you want to use first. For the back number in the parentheses, I only have 1 and 5. But my front number now has all the different variations. So decide whether you want to use the 1 and 12 first, the 2 and 6 first, or the 3 and 4 first. Remember, whatever one you pick, you may have to do it twice. One with the 1, then the 5, then one where you switch the order. Last time when we used the one with the 1 and the number, it was kind of big. So I don't think I want to try that one. So instead of starting with this first one, I'm going to start with this last one. Front parentheses, I have a 3. Front parentheses, I have a 4. Split the x's. There's 2, so I do 1 in the front of each one. That's my 2 fronts. Now I have to figure out my back. So if I do the 5 in the back, then the 1, let's see what we get for that. I need them to be the same. So I'm going to add, and they're going to end up being both positive signs. I went ahead and put the signs in because once I know it's the same, it just makes it easy. So 5 times 4, that would be a 20. 3 times 1, that would be a 3. That's going to add to give me a 23. Not what we wanted. So I'm going to reverse the order. If I want, I can reverse the order of the back one, but to stay consistent with what we were doing before, I'm going to reverse the order of the front ones. I'm going to put the 4x up front and the 3x in the back and leave the 5, then the 1 for the back half of the parentheses in the same order it was before. So now when I do my 5 times 3, that's 15. 4 times 1, that's 4. Adding that will give us 19. That's not what we need. That's not giving me my 17 that I need. So, and I can make little notes on here. This 3 times 4, we know it's not it. So now we can try the 2 and the 6 with the 1 and the 5. So now I've tried the 2 and the 6. So now I've tried the 2 and the 6 with the 1 and the 5. Where I have the 5 then the 1, then where I have the 1 then the 5. And it didn't work. None of them gave me my 17x. So now I have to try that 1 and 12. So when I do the 1 and the 12 with it, if I have the 1 up front in the front parentheses, 12 up front in the second parentheses, the 1 in the back of the front parentheses, the 5 in the back of the second parentheses, when I take care of that, checking the insides for that O and that I piece from FOIL, I get my 17x that I needed. So the 12 and the 1 is actually what I needed. I know they're going to have the same sign and they're both going to be positive. So there's my answer. Let's do another one. So in this one, I have more than one set of factors on both the first number and the last number. So now it's more to play around with. So I would need to check the factors of 1 and 25 with both the 1 and the 6 and the 2 and the 3. I would need to check the factors of 5 and 5 with both the 1 and the 6 and the 2 and the 3 and reverse them. So this is why I said you can kind of pick and choose who you want to use. So I still don't like the big numbers, even though that last one ended up being what I needed. So I'm not going to go with the 1 and 25 first. I'm going to go with the 5 and 5 first. And hope I luck up. So in the front of both parentheses, I put a 5. Our variable is n. It's 2 of them. I split it, 1 each in the front. Now I'm going to try the 5 and 5 with the 1 and a 6. And I'm going to cross my fingers. The 5 and the 5 is easy to use because I don't have to worry about reversing the back order because it's the same two numbers up front. So it makes for a quick check. I think I reversed the colors. Yes, I did. I reversed the colors I was using. Third term had a minus, so I need different signs. When I look in front of the second term, it's a minus, so the higher product is going to have a minus. So 35, if I subtract, I'll get a 25. Even though I reverse the order of the signs, I'm not going to get my 5. So that one didn't work. So now I need to try it with the 2 and the 3. I'll need to flip the order of the 6 and the 1 because the two fronts are the same number. So now if I check those middle pieces, the 2 times 5 gives me the 10n. 5n times 3 gives me a 15n. If I subtract the 15 and a 10, I'm going to get a 5. That's the one I want. So now I deal with my signs. The higher needs to be the minus. So the 10 is high. I'm sorry, not the 10. The 15 is higher than the 10. So I need the 15 to have the minus, which makes the 10 have the plus. The higher is 15, so the 15 gets the minus, which makes the 10 have the plus. That plus in front of the 10, I'm going to follow it right on up. And then it makes the other one have a minus. And that's what I'm going to use for my answer. The key to these is staying organized and methodical. Let's do another one. First step is always going to be to factor out my greatest common factor. And I am going to have a greatest common factor. There's an x in each one of those terms. So I'm going to be able to factor out an x from the 6x cubed minus 31x squared plus 5xy squared. So I factor out my x. I figure out what I leave behind. X is going to go into the 6x cubed and leave me with the 6x squared. X is going to go into the minus 31x squared and leave me with the minus 31x. X is going to go into the plus 5xy squared and leave me with a plus 5y squared. Actually, I have a typo on this problem. Please fix it. That middle piece was supposed to have a y. It was supposed to be 6x cubed minus 31x squared y plus 5xy squared. So that means this x piece is going to get to copy down. I have to figure out the parentheses. So I'm going to need my factors of my 6. 1, 6, 2, 3. And I'm also going to need my factors of my 5. 1 and 5. That's what I have to play around with. I'm going to need same signs, because the third term is positive. And both of those same signs have to be a negative, because the second term is negative. So I already know my final answer. I'm going to copy down this x, and I'm going to have another set of parentheses. So let's figure it out. So I'm going to use the 1 and 6 first. The first term had x squared, so I'm going to have 1x and 6x. On the back one, I only have a 5 and a 1 to play with. So I'm going to put the 5 up front, 1 in the back, and maybe I'll look up and get it. Five times 6 is 30. X times 1 is 1. X, so 30x and 1x. If I add those, I will get my 31. But I need both signs to be a negative, so I just throw negatives in front of them. The more you do these, the better at guessing you get. Last one. Two x squared minus 7x minus 3. There's no common factors to factor out. I need my factors of my 2, factors of my 3. They each only have one set of factors, so that'll make this one go by fast. So I'm using the 2 times the 1. I just decided to put the 2 up front, and the 1 in the back. X squared is up front, so I split it, an x and an x up front. Then I go to my 3. I'll put 1 in the front, 1 in the back. I need to subtract. To get that negative 7. When I check my O and my I for my FOIL, if I subtract those, I'm getting a 5x. Not the 7x I wanted. I would have had to add to get that. So it's not going to work because I said I needed to subtract. So now I'll reverse it. And when I reverse it, I'm going to have 1x. I'm still not getting the 7x. I don't have any other numbers to try because I only had the 2 and the 1 to use up front with the 1 and 3 to use in the back. If I had another set of factors for one of them, I'd try the other set, but I don't have anything else, and I couldn't do anything, so it's prime. While I was working number 3, I noticed a mistake on, while I was working number 5, I noticed a mistake on number 4. On number 4, let's go back to it. On number 4, I forgot that I had a y in the back, a y squared in the back. That meant when I was trying my parentheses, I needed a y to split in the back. So it should not have been x minus 5, but x minus 5y. And it shouldn't have been 6x minus 1, it should have been 6x minus 1y. So the correction to the final answer is x times parentheses x minus 5, close parentheses, and then another set of parentheses with 6x minus 1. And that's our factoring. We still have a little more factoring to learn, just not in this recording.